right, so today we are starting trig, and I'm very excited because it's one of my most favorite topics in math in general. We are going to use trig for most of the rest of the year, and it's a super important thing. If you were in physics, you already sort of know some trig. You might not really understand the whys because unfortunately she has to kind of just tell you do this, and you're not really sure why you're doing it maybe mathematically because we haven't gotten to it yet, and our courses just don't line up very well, and there's really not a good way to make that happen. But let's talk about the Greek alphabet first of all. You can read this I'm not going to read this to you. You can read this for yourself later if you're interested. But the Greek alphabet is a very important thing in your math and science classes because you have already used quite a few of these if you don't know. So your Greek alphabet is alpha, beta, gamma, delta, epsilon, zeta, eta, theta, iota, kappa, lambda, mu, nu, psi, omicron, pi, rho, sigma, tau, upsilon, phi, chi, psi, omega. All right. You may have to memorize this or know it in a class that you take at some point, probably not in high school. We used to kind of do it just for fun, but we don't have time just for fun stuff anymore. But I had to memorize it in college as I was a math major, but it's not because I was a math major, it was whatever class I was in. Anyway, but you need to be familiar with these. You are familiar with quite a few of them. Some of them look like letters from the English alphabet, but not all of them, and they don't necessarily correspond to what you would think they would. But alpha and the omega, the beginning and the end, because it's the beginning and the end of the Greek alphabet, right? If you're going to be in a fraternity or a sorority in college, you'll probably know the capital ones because that's how they name them. Phi is something that you would eventually talk about in your math or science classes and its value and meaning. Sigma, we're going to use the capital sigma towards the end of the year if you haven't already. It's the summation symbol. So they have one of the reasons the Greek alphabet is used is because it's universal. Okay, so they have certain meanings, like pi. You've known about pi forever. So the lowercase pi, it doesn't matter what language you speak, what country you're in, everybody knows what pi is. Everybody knows what sigma means, or everybody that's learned it anyway. And let's see, Then the beginning, alpha, beta, and gamma, those get used a lot. You should have heard of gamma rays at some point, right? Delta, the capital delta symbol, anybody know what it means? It means changed. Very good. Delta means change. So it means change no matter, again, what language you speak, what country you're in, what math or science you're in. Delta means change. Like it always has the same meaning for you. And then theta is the one that we're going to use today, actually, the lowercase theta. So when we get into trig and then you get into the higher maths and sciences, your unknown variables for angles change from just x, y, and z that we're used to theta being the most generic, like x. Like if you just have a missing angle, it's theta. You use it kind of like x. But then once you've already used theta, like if you already used x, that's when we use y and z or whatever. So once we use theta, then we'll usually use alpha and beta and gamma for angles, because then they just kind of work as variables, the lowercase ones anyway. All right, and if you've been paying attention to this record-breaking hurricane season that we are in, like we have just blasted the records out of the water, literally, for the hurricane. And not only did we go all the way through the English alphabet, but I think yesterday I saw that we have an iota already. We're already at iota. What happens when we finish the Greek alphabet? I have no idea, and I really hope we don't find out. But we're a few past the record from however many years ago, so it's kind of crazy. But anyway, so this is just kind of an FYI. I'm not going to make you memorize it, but you need to be familiar with them. The little thing that's up there is kind of interesting if you want to read it. I wanted you to have it open in Cami, not because you even have to write anything on it, but I just want you, if you just hit turn in, then it'll put it in the same Cami folder with all the rest of your notes. It's just kind of trying to help you organize it. And just like there's an ABC song that we all learned when we were itty bitty, there is a song for the Greek alphabet as well. So I'm going to play that for you. And in order to make all this work, I've got to, oh no. Well, I don't know what's going on with Zoom there. But let me turn this off.
Alpha, beta, gamma, rays, delta, epsilon, hey, 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 zeta, eta, theta, iota, then there's kappa and lambda, mu and and xi, xi, omicron, and then there's pi. Rho and sigma and tau 2. Upsilon, it starts with U. Phi and chi and psi are fun. Omega, and then you're done. Learn all that and then you're set. That's the whole Greek alphabet.
So now you know, and if you did need to learn it for a class or something, having a song, I mean, hopefully by now you know, if you kind of make a little song out of things, you just kind of remember them a little bit better, so you can always come back to this if you had to learn it. All right. Let's talk about some trig stuff then. So if you have this, you can leave the Greek alphabet open if you want. If not, you can just hit turn in Cami and it'll stick it in that folder. And Friday, one of the things we're going to work on is actually getting digitally organized now, like I've been saying forever. All right, so we're going to look at trig functions. Let's see, let me put that back in there. All right, so the majority of this is going to be a review from geometry. In geometry, you get your basic right triangle trig, which is super duper important. So this says trigonometry is the study of the relationship among the side and angle measures in triangles. And so trigonometry literally means triangle measure. Okay. A trigonometric ratio, so a ratio, usually we're making a fraction out of it, right? It compares the lengths of two sides with respect to an acute angle, which is theta in a right triangle. Until you get to trig, most of the time when you're comparing sides of two different figures. Like, I'm going to put this side of figure A over this side of figure B, and I can get my ratio of it. But your trig ratios are ratios of sides within the same triangle, okay, which makes it a little bit different. And then a trigonometric function is a rule defined by a trigonometric ratio. So trig functions, trig ratios, we're going to get into all of that. All you learn in geometry is the stuff that goes with the right triangles. Trig definitely applies to things that are not right triangles, but as far as we're concerned right now, we're only working with right triangles until we get into the other stuff, okay? All right, so we define this theta, like whatever angle we're actually working with, here's our theta, and then you label your right triangle accordingly. Across from theta is your opposite side, so that can be O. Across from the right angle is your hypotenuse. Yes, the hypotenuse is always the longest side, but if you don't have any measures there, how do you know which one's the longest side? Well, it is the longest side because it's across from the biggest angle. And then the other side that's attached to theta is your adjacent side. To understand the right, because technically both of these are adjacent, but the fact that this is hypotenuse is more important. You can't have two adjacent sides. Now, there's an acronym that helps you remember the ratios. The acronym kind of sounds like, to me anyway, an Indian chief's name. Anybody remember what it is? Sohcahtoa. Very good. So it is Sohcahtoa, and you got to spell it right to use it right. It's S-O-H-C-A-H-T-O-A. Sohcahtoa. So when you first learn this stuff, you learn three. You learn sine, cosine, and tangent. And then hopefully you were told there's actually 6, but we just learned 3 at first. But once you know the first 3, the second 3 are super easy because they're just reciprocals. So what this stuff here means is sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. So taking that, and we're going to write those in here. So sine, opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So the other 3 that you most likely haven't learned yet are cosecant, secant, and cotangent. They are just the reciprocals of the first 3, which we should have down pat. All right? And here's how the reciprocal relationships work. Tangent and cotangent are reciprocals of each other. Their names make sense, they go together, that's all great. So since tangent is opposite over adjacent, cotangent is adjacent over opposite. But clearly, sine and cosine are not reciprocals of each other, right? Doesn't work that way. But if you know, sine and cosecant are reciprocals, and cosine and secant are reciprocals. If you notice, every pair of reciprocals only has one co-name in it. That's how you can keep them straight, okay? You know cotangent and tangent go together. So then sine has to be the reciprocal of cosecant. So this means this is hypotenuse over opposite. And then cosine and secant, without a co in it, are reciprocal. So this is hypotenuse over adjacent. And SOHCAHTOA is, again, really all you need for that stuff. It's okay if your thought process goes through, like if I say, what is secant? If you can't just say, oh, it's hypotenuse over adjacent. If your thought process is, all right, secant's the reciprocal of cosine. Cosine is adjacent over hypotenuse, so this is hypotenuse over adjacent, right? You kind of get to secant through cosine, and it's easier than having to like learn another three, right? Just relate it all together. All of this stuff, it becomes a huge, huge part of everything we do for the rest of the year. It's a huge, huge part of calculus. You are going to struggle in here and struggle in there if you don't get this stuff down. I am going to help you along the way. Like, I have things to help you learn and remember and understand this stuff. You just have to stay with me. You have to believe me when I say how important it is, because sometimes I feel like you're like, whatever, she says everything's important. It really kind of is, but I'm telling you, like, these things, there's a lot of things that if you don't remember it, you can look it up or you can figure it out, but then there's certain things that, like, you just have to know. Otherwise, you're not going to be able to get through things. All right, so since they are reciprocal functions, so it says, because cosecant, secant, and cotangent ratios are reciprocals of the sine, cosine, and tangent ratios, they are called reciprocal functions. So yes, cosecant is going to be hypotenuse over opposite, but cosecant is the reciprocal of sine, so cosecant theta is 1 over sine theta. And secant theta will be 1 over cosine theta. And cotangent theta will be 1 over tangent theta. So you have to kind of understand them both ways, like that, you know, it's the reciprocal of that plus it's, you know, hypotenuse over adjacent or whatever. And you have to know how to say them correctly, so you sound like an intelligent person. This is sine, cosine, and tangent. It is not sin, cos, and tan, all right? And it's not, you know, what would you say here? Like, you're not just sounding them out, right? Like, it means something. So this is cosecant, secant, and cotangent, not second cot. That makes no sense. And again, I don't know what you would say for the first one. So make sure you know how to communicate correctly with it. We don't have to write the whole word out. That's why we have abbreviations, but we have to know what they mean. All right, so let's look at some examples here. We're going to find the exact values of the 6 trig functions of theta. All right, so here's theta. Since I'm using trig, I'm going to label my triangle. This is the opposite side. Across from the right angle is the hypotenuse. And then the last one's the adjacent side. I do them in that exact order every single time. And the more consistent you are, the better. I do opposite and then hypotenuse, then adjacent. I'm not saying you have to. I'm just saying consistency means something here. All right, so sine is opposite over hypotenuse. So this is going to give me 4 over 4 square root of 5. Now, am I allowed to leave it like that? No. First, I can reduce the 4's, right? And then this is going to give me 1 over the square root of 5. Am I allowed to leave it like that? No. What's wrong with it? I have it. Yes, exactly. I have a square root in the denominator, so I have to rationalize the denominator. And when I do, what does this end up being? Yes, exactly. Square root of 5 over 5. That is my answer. So all 3 of those fractions have the same value, but the one that I boxed is the one that's the reduced or the simplified version. Even though it may not look like it to you, that's what it is. Okay, so cosecant is the reciprocal of sine. So I could take the reciprocal of this and then re-rationalize, but since all 3 of these are equivalent, I can just take the reciprocal of this one. That means it is square root of 5. Because that would be hypotenuse over adjacent, and then the 4's would cancel out. All right, cosine, adjacent over hypotenuse. So this is going to give me 8 over 4 square root of 5. I'll reduce the whole numbers first, and that gives me 2 over square root of 5. So once I rationalize, what do I end up with? Yep, 2 square root of 5 over 5. Secant is the reciprocal of cosine. So I have like 3 things I could choose from here. I'm going to make my life easiest. I'll just take this one, and I get the square root of 5 over 2. Tangent theta, opposite over adjacent, so that is 4 over 8, which is 1/2. So that means cotangent is 2. Now, if I wasn't asked for all 6, and I was just asked for, let's say, secant, then I could just set up hypotenuse over adjacent. You know, I wouldn't have to like do all that to get there. But any questions at all? All right, so let's look at number 2. On number 2, here is my theta. So this is my opposite side. Across from the right angle is the hypotenuse, and then this is my adjacent side. All right, so I don't have the hypotenuse. I need to find the hypotenuse so that I can do all of these ratios. I mean, at this point, I could do the tangent ones, but I'm going to have to do them all. So how am I going to find the length of the hypotenuse? Okay, I can use Pythagorean Theorem. So I will do 6 square root of 3 squared plus 6 squared equals h squared. Okay, so I know that 6 squared is 36. What is 6 square root of 3 squared? Or how do I actually find it? I will tell you, it is not 18. What is it? Or what numbers would I have to use to find it? What would I do? Say that again? I just didn't hear you. Not just well, yes. So I'm going to take this square, and I'm going to square them both. So I'm going to have to square the 6 and square the 3. I'm sorry, and square the square root of 3, so I get 36 times 3. I don't know if that's what you were saying, but so I get 36 times 3, and that is 108. Most people that try and type that in on a calculator would get 18, so it's safer to understand the concept so you can get it done yourself there. All right, so what's 108 plus 36? 144. So the square root of 144, so if I take the square root of both sides, I get plus or minus 12, but this is a side length, so h is just 12. Now, absolutely nothing wrong with what we just did. However, did I actually have to do Pythagorean Theorem to figure out that that was 12? Why not? Okay, we could figure it out through trig. What could I do besides trig? Very good. So it's actually a special right triangle. So this is a 30, 60, 90 triangle. It just didn't tell you it was. If it had told you that, maybe we'd have thought of that, or maybe not, because it might have been a while. But if this is, let's say that this is, we'll call this, I don't want to write it on there and confuse you, but if this is S, the hypotenuse is 2s, and then this is s times the square root of 3. So anytime you have two sides and one of them has the square root of 3 times it, then it has to be a 30, 60, 90, so this would just be 12. But again, Pythagorean Theorem is fairly simple. You know how to do it. It didn't take us that long, and so the fact that we didn't notice that is fine. But sometimes you don't have enough information to do that. We still need to know special right triangles, but very good. And it's fine if you don't necessarily know what it's called, but you can do it. It's good to know. If you don't know what it's called, that's fine as long as you can figure it out. All right, so let's figure these out now that we have all that. So your sine of theta is opposite over hypotenuse. So we get 6 square root of 3 over 12. So all I have to do is reduce the 6 and the 12, and I get square root of 3 over 2. Then I'm going to need to take the reciprocal of that to get cosecant. So that's going to be 2 over the square root of 3. But now I have to rationalize. So what's this called? What's this called? I'm sorry. No. What would I get? My brain. 2 square root of 3 over 3. It's called the answer is what it's called. There you go. All right. cosine adjacent over hypotenuse, so this is just 6 over 12, which is 1/2, which means secant is 2. Tangent, opposite over adjacent, so that is 6 square root of 3 over 6, so that's square root of 3. Cotangent is the reciprocal, so that's 1 over the square root of 3. When I rationalize, I get square root of 3 over 3. Okay. Any questions at all? Alrighty. Let's look at the next one. So on the next one, same kind of thing, but instead of them giving us a triangle, it says use the given trigonometric value to find the remaining function values. So they gave me the tangent of theta. So I'm going to use that to label a triangle. This doesn't guarantee that these are my side lengths, because I could have set it up and reduced it, and then that's what it reduced to. Just like we reduced some of the other ones on the front, our answers weren't technically the side lengths, they're just the ratios of them. But that's okay, they're not asking us for the exact side lengths anywhere, they're just asking us for the ratios. So I'm going to draw a triangle. Since this is theta, this is the opposite side, this is the hypotenuse, this is adjacent. Tangent is opposite over adjacent, so that is 7 over 24. I need the hypotenuse. This, not a special right triangle, because it's not 7 times the square root of 3, and the two sides aren't congruent. So I'm going to use Pythagorean Theorem. So 7 squared plus 24 squared equals h squared. What is 24 squared? Very good. 576 equals h squared. You should know your perfect squares up to 25, because those things can't be slowing you down. So then when I add 49 plus 576, what do I get? 625. And that means h is equal to 25. Now, did I actually have to do Pythagorean Theorem on this one? It's not a special right triangle. But the fact that all 3 of these came out to whole numbers, do you know what that's called? It's a Pythagorean triple. So if you know your, like 3, 4, 5, if you know your Pythagorean triples, if you had 7, 24, you'd be like, oh, I know it's 25. Now, is it worth going and actually learning all your Pythagorean triples? Probably not. Okay, knowing your special right triangles, yes. Knowing your, like, I know some of these, I've never actually like sat down and like tried to learn them. It's just because they come up so often, you just kind of know them, but totally not worth your time like making flashcards or anything. Because again, Pythagorean Theorem is fairly simple, especially when you get whole numbers. All right, y'all go ahead and get your ratios done for number 5. And I will tell you, part of your assignment on Delta Math, there are 2 timed sections on there. Don't let the timed sections freak you out. You have like 100 seconds to get 10 of them right, which is way more than enough time. But one other thing about the timed sections in Delta Math, once you get your 10 right, it'll let you keep going. You can do 200 of them and it'll let you keep going. So make sure you're paying attention. So I think we get so focused on it and trying to do them fast, like, why am I keep going? It'll let you know when you've actually reached what you need. But one of them is, it would give you the triangle, like basically give you all of this information here, and then you just have to come up with these. And even if they could reduce on the timed part, you don't have to reduce. You're just like setting them up to make sure that you understand which is which, and it's really not that bad. So don't let it like freak you out. Any questions at all right now? It's way easier when you don't have to reduce them, right? All right, so let's look at number 4. So again, they give me a ratio, which is really just a whole number, but that really is over 1, right? So I'm going to draw my triangle. This is my opposite, this is hypotenuse, this is adjacent. Okay? And so secant is the reciprocal of what? What's the secant? Cosine, right? Because we've got to have a co in there. So secant is the reciprocal of cosine. So since cosine is adjacent over hypotenuse, this is hypotenuse over adjacent. So I would label the hypotenuse as 4, the adjacent as 1, and then I'm going to have to find the opposite. Okay. So you go ahead, find the opposite side, and get your ratios done. Any questions? I want you to notice something, because this kind of, when you're thinking through rationalizing and doing stuff, you should hopefully get to a point on some things where you don't have to actually think through the whole rationalizing process every time. So notice if I have the square root of 15 and I want to take the reciprocal of it, it just becomes a square root of 15 over 15. So if I have the square root of 5 and I want to take the reciprocal, it's the square root of 5 over 5. If I have the square root of a monkey, it ends up being the square root of a monkey over a monkey. It's the same every single time, so you don't have to go through the whole process, right? Any questions at all? All right, so let's talk about trig values of special angles, because here's where things get really important. Everything we did so far, if all we did was sine, cosine, and tangent, not the reciprocals, it would have been 100% review. The new part of that is, hey, we have 3 more, okay? So this also is pretty much a review, but this little chart here, come the week after Thanksgiving, we're gonna have to know this thing, have it. I don't like the word memorize, because that's not really what we're doing. We're learning it. I'm going to give you a way to learn it and understand it and come up with it quickly. So again, you just have to stay with me. I'll give you the little tools that are very, very helpful, because I know some people can just look at stuff and they just know it, and that's very few people, but don't pay attention to those people because they'll stress you out. It's just good for you, but I got to figure out different things. So I will help you with this. Today, all we have to be able to do is actually come up with them and understand them, and then I'll show you why they're important and why we need to know them. All right, so this says angles of 30, 60, and 45 are used frequently in trigonometry, and that is pretty much an understatement, a lot. You got to know them. And not just in trig, but in pre-calc, calculus, your higher maths and sciences for sure. So we're going to use our knowledge of the side relationships and special right triangles to find the values of the trig ratios. Okay, so if I have a 30, 60, 90 triangle, and when you learned your special right triangles, now whoever you learned it from, they may have used x or some different variables. X is a really bad idea, and I'm not even going to get into why right now, but use s. So across from 30 is my short leg, so this is s. The hypotenuse is 2 times s, and the long leg is s times the square root of 3. And that's what Angela was referring to earlier. So that's what you would set up. So you could set up little equations so you could solve for sides of a special right triangle. So we're not solving for sides of a special right triangle right now. We want to just see the ratio relationships, which basically means I don't want any variables. So if I said, all right, I'm going to let the short leg, this value is going to be 1. Well, maybe. It's going to be 1. So if the short leg is 1, the hypotenuse is 2 times 1, so it's 2. The long leg is 1 times the square root of 3, so it's square root of 3. And so that's what it looks like in a in a ratio relationship. For the 45, 45, 90 triangle, I don't use S because the S is really for short leg. These two legs are congruent, so we're going to use L. So leg, leg, and then the hypotenuse is leg times the square root of 2. So if I let one of the legs of the 45, 45, 90 triangle equal 1, then the other leg equals 1, which means the hypotenuse has to be square root of 2. So we're going to use those values in pink to come up with our values down here. So we're going to start with the 30-degree angle. Okay? The sine of 30, sine is opposite over hypotenuse, so it's 1/2. Cosine of 30, it's going to be adjacent over hypotenuse, so that is square root of 3 over 2. Tangent of 30, opposite over adjacent, so that is 1 over the square root of 3, but I really need that to be square root of 3 over 3. So now that I have those three, I can find cosecant, secant, and cotangent. So cosecant's a reciprocal of sine, so it's just 2. Secant would be 2 over the square root of 3. When I rationalize it, that gives me 2 square roots of 3 over 3. And then cotangent's the reciprocal of tangent, so it's just going to be square root of 3. So again, right now, we're able to come up with it because we understand special right triangles and we can understand the trig ratios. And if I asked you what's the cosine of 30, you could come up with the square root of 3 over 2. But again, come pretty soon, you're going to have to just know that it's the square root of 3 over 2. But again, I'm going to give you ways to get there. All right, so we're going to skip over 45 for just a minute. We're going to do 60. So if I take this 60-degree angle and I want the sine, that's going to be the opposite over hypotenuse. It is square root of 3 over 2. Cosine of 60 is going to be adjacent over hypotenuse. That is 1 over 2. Tangent of 60, opposite over adjacent, that is the square root of 3. So before we go any farther, I just want you to look at sine, cosine, and tangent of 30 and 60. Do you see how the sine of 30 is the same value as the cosine of 60? And the cosine of 30 is the same as the sine of 60. Okay, because we're basically just, flip-flopping the angles there. All right, so then cosecant, it's going to be the reciprocal of the square root of 3 over 2, which we already found. It's 2 square root of 3 over 3. Secant is the reciprocal of 1/2, which is 2. Cotangent is the reciprocal of the square root of 3, so that is square root of 3 over 3. Now, so far, all those numbers we wrote in purple, yeah, we wrote down, 12 numbers? But it's kind of the same numbers over and over again, right? Sometimes that can make things confusing, but it won't. Like, that'll actually help if you understand big picture. It's not like there's all these different things we have to keep straight. It's a few of them, and we just got to get them put in the right places. All right, so now let's look at 45. Sine of 45. So I'll pick this one. They're both 45. So opposite over hypotenuse is going to be 1 over the square root of 2, which is the square root of 2 over 2. Cosine of theta, or 45, adjacent over hypotenuse, that's also 1 over the square root of 2, so that's also square root of 2 over 2. So sine and cosine of 45 are the same number, because the angles are the same, right? Then tangent, opposite over adjacent, that's 1. Cosecant's the reciprocal of 45, so that's just square root of 2. Secant's the reciprocal of cosine, square root of 2. Cotangent's the reciprocal of tangent, reciprocal of 1 is 1. Okay. Any questions at all? All right, good deal. So again, this, like, when you're looking at things like this, like, look at the big picture. Just start kind of looking for patterns. I'm not telling you to start memorizing things or anything like that, because again, I will kind of lead you into that. You just got to stay with me and believe me when I say you need to actually do it, and we'll all be good. All right? Any questions at all? All right, awesome. Okay, well, I got to figure out why I cannot. Am I not actually? I am recording. Am I not recording? I am recording. Yeah, click here to pause.